All right, here we go. Oh, here she comes. Okay. So let's. Yeah, we already put you in. All right. Yesterday, you remember working on our compass yesterday? Okay, so now we're going to see how much you remember. Problem E says, sketch a diagram of a ship on the given course. So, please remember what your compass looks like. Not the whole thing, you don't have to draw the whole thing with all the subdivisions, but remember that on your compass, straight up is 0, 90, 180, 270. So if we are drawing a ship, you don't have to draw the ship, just draw an arrow, 35 degrees, would you agree that that would look something like this? That would be our ship, 35 degrees? And 128 degrees would be down here like this. And we're just approximating placement. We gotta get it in the right quadrant, okay? And then where's 310? 310 would be all the way over here. Okay? Everybody good with that? All right, problem F. The captain of this boat follows a 38-degree course for 2 miles. All right, so let's draw that, remembering that that's 0 and 90. So if we're doing a 38-degree course, that would look like this. Would everyone agree with that? This angle right here is 38 degrees. And this length is 2. Because it's 2 miles. He went 2 miles on that course. All right, now what's he doing? He's changing course now. So I'm going to go ahead and right here, I'm going to set up a new compass. So a new labeling system here. And from this point now, he's going on what course? What is this course? 47 degrees. So that's a little bit more than half. So maybe like this. That's supposed to be a straight line. I'm not sure why I'm wobbling. But that's a 47-degree course right here. And how long is that one? 4 miles. So now would you agree the ship is right here? Now we're not doing it today, but later in this chapter, we're going to say, okay, the ship is, all of a sudden he's in distress. He's sending out an SOS, and we have to send a rescue boat from the original port out to get him, and we're going to figure out how far that is and what angle, what course that he has to go on. But first we have to draw the original course. So is everybody okay with that part? That's all we're doing today, because we have ordered everything here. All right, letter G. Got a picture this time already drawn for us. One travels and the other travels. If they travel at the same speed, how far apart will they be when they are 25 statute miles from the pavement? All right, let's look at this and see if we can figure it out. This boat is 42, this boat is 4230. And this boat is 5212. Traveling at the same speed. They're 25 miles out, so this is 25 and this is 25. And we want to know how far apart they are. Anybody have an idea? Well, if we do SOHCAHTOA, now we haven't really talked about that yet, but you've talked about it in the past. But when you say SOHCAH, so is S-O-H, CAH, C-A-H. What does the H stand for? Hypotenuse. And if we're going to do that, we have to have a right triangle, right? So I'm not going to jinx that whole idea, but I'm going to say you would need a right triangle to do that. Did you have another idea? Now, think about this for a second, guys. Would you agree that there's a big circle here with a radius of 25? And if we found this arc length, and we found this arc length, could we subtract them to get that guy right there? Or could we find this angle and just straight up find that arc length? How would we find that angle? This angle right here. How would we find our pink angle? Well, now wait. This one's 5212.
You get 5212 minus
and this one's 4230. So could we just subtract them?
Yeah.
All right, now, be careful. Because the problem is, we're gonna have to do some borrowing.
Can you not do that in your calculator?
I bet you could. I bet you could do it in your calculator.
It was a question.
And we're gonna go to our calculators anyway. Let's see what happens. I never tried it, but I bet you could. So 52, everybody remember how to get 5212? Remind each other, help each other. Now, I have no idea if this is gonna work. I think it's going to work.
They give you a decimal.
That's okay, that's fine. We're good, we're good. I'll live with the decimal, that's fine. That's fine. So this angle, if you didn't get it typed in, please ask your neighbor. You need to be able to type this in. That was a good idea to have, Joe. We're gonna do it by hand, but the calculator will do it for me.
Nice, Joe.
9.7? Now, what's the unit on that? 9.7 less degrees. Okay, now that's problematic because if we're going to find arc length, and I love that idea, we need radius, which is 25, times radians. So this is 25. And now I need my radian measure. So it's actually easier when it's in a decimal form. So pi is to 180 as something is to 9.7. I got 9.7 pi over 180. I'm just gonna leave it that way. And now I'm gonna type this into my calculator, and that is gonna be very close to the answer. 25 times 9.7 times pi divided by 4.234. Now, before we go farther, I want to stop and make sure that we're all on the same page here? There was a lot of stuff happening there. Did everybody keep up with all that? Jack, what about you?
Yeah.
You sure?
Write it down.
Okay. Now, a minute ago I said that this was gonna give us our answer right here. Actually gonna give us really close to the answer. Because remember, this gave me the arc length, right? The actual distance between the two ships is a line. But aren't they gonna be really, really close? They're gonna be really, really close. So the real answer is gonna be slightly smaller than 4.234 because it's a straight line and not an arc. But I think this is close enough. I love the way you did that. Good job, Caitlin. It's nice. You good? All right, my friends. Now, letter A. Find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. Okay.
One revolution.
Let's
I have one.
talk about this.
Thanks.
So I'm gonna start with the first tire, which is what? A Ford Taurus, and the diameter is 26.16 inches, and I know we are turning at 800 revolutions per minute, and I wanna find the speed. I know that most of you probably can fly through these problems because you did problems very similar to it in chemistry. But I want to go through it, at least this first one, to make sure that we are all on board. I don't want anybody just sitting back and pretending. I want everybody to be on board. So here's my suggestion to you. Start with whatever rate you have. So right now, I have 800 revolutions per 1 minute. So that's my beginning point. I am gonna do a whole bunch of stuff, and in the end, I wanna end up with miles per hour. Does everyone understand that? So I'm starting with this ratio, revolutions per minute, and I'm gonna do whatever I need to do to end up with miles per
Stoichiometry.
hour. It's exactly what it is. You've done it before. So,
60 minutes.
okay, so Elijah says, I have minutes, I need hours,
60 times.
so I know that there are 60 minutes in 1 hour. Would everyone agree with that? Now, make sure you're setting your fraction up like that because you need minutes to cancel out. Right? So one's on the bottom, gotta have the other one on the top. Now you're good. We're not gonna mess with that anymore. We're finished. Now we gotta get from revolutions to miles. And here is the key. Think about a wheel. Here's your tire. If you put a blob of paint on it and roll it down the driveway, so you got a blob of white paint, black driveway. As this rolls down the driveway, isn't it gonna leave little paint marks on the driveway? And how far apart are those paint marks gonna be?
26 points.
No, they're gonna be a revolution, aren't they? Every time the wheel goes around. And a revolution is a circumference. A revolution is a circumference. A circumference. Every time that wheel goes around, that's the circumference. It's gonna leave a blob. So this is one circumference, which is 2 pi r. So one revolution is 2 pi times, well, wait, this is the diameter, so won't it just be 26.16 pi
Why, because they already gave
Oh.
us.
inches? Okay, so this is the key right here. This is the part we always, if we miss it, this is where we miss it. A revolution is a diameter. And diameter is 2 pi r, and 2r is the diameter, right? So circumference is 2 pi r. Okay, so now the revolutions are gone. And what do I need to do now? It's easy. I need to get from inches to miles. So I know that 1 foot is 12 inches. And then I hope you know this, 1 mile is 5,280 feet, yeah. Mrs. Ford, do I need to know that? Yeah. So if you don't, learn, memorize, 5,280 feet is a statute law. And then see what happened, guys? What are we left with? After all that messing around, we have hours on the bottom and miles on the top. Bless you. All right, so now we're ready to type it in. So I'm gonna type in, this is all multiply here on the top. So I'm gonna multiply all these numbers together. So that's gonna be 800, I wish you were doing it with me, times 60, times 26.16 pi. Okay? Oh, that is not what I got. I haven't divided yet. Yeah. So I've multiplied my whole top together.
31908.
And I have 3944.
31908.
3944 for the top.
Yeah.
Yeah.
Oh, wait, hold on. That's what
Now, here's another place to be careful. Aren't you gonna divide by the 12? Yeah? But you're also gonna divide by the 5,280. These are both divisions. So divided by 12, divided by 5,280. The wheel is traveling 62.261 miles per hour. Is that what you got?
Yep.
So 800 times 60 times 26.16 pi, use your pi button, divided by 12 divided by 5,280. Did we get 62?
So then you just plug in like all the different diameters to where.
Yeah, yeah.
Didn't need to do.
Okay. All right, so would everybody do, right now, would you do the Dodge Charger for me? Do the Dodge Charger. Everybody's doing the Dodge Charger. All you're doing is changing one number.
On the next page.
Okay, so 800. Oh, wait. Where did that come from? That applies to the individual. It should be that. So Caitlin's already observed, and maybe you did too, but the setup's gonna stay the same, you're just gonna change that number right there. That's the answer?
Yeah.
Well, that doesn't sound right.
I don't know about that one.
I got 68.139.
Wait, I didn't.
Oh, we did forget the pi.
So take your answer times pi and you should be fine. Whatever you got, Richard.
Should you multiply all the toppers?
68,
Yes.
68.1.
All right, are we good there, folks?
Yeah, what you get?
By the way, does it make sense that the Dodge Charger is going faster than, it's going faster than the Ford Taurus?
Yeah. Yeah.
Yeah. They're both 800 revolutions a minute. So the bigger tire is covering more ground in the same amount of time. All right, last opportunity. You good? Everybody getting 68.139? All right. We're going to problem I now. Okay, Kathy is racing on a bike with 13-inch radius tires. She is traveling at a speed of 44 feet per second. How many revolutions per minute is her bike, or are her bike tires making? All right, so let's start with what we know. 44 feet in 1 second. That's what we know. And we ultimately want to end up with revolutions per minute. Okay, so what do you want to do?
1 minute is 60 seconds.
Okay, so we can take care of the time easily enough. So we know that 60 seconds are 1 minute. Everybody okay with that fraction? Setting it up that way? I hope so, because I want these to cancel, right? Now, what do we know about a revolution? Just said a revolution is a circumference 2 pi r.
Oh, those are 26
Right?
pi.
13.
So 1 revolution is 26 pi inches. This is a radius this time, not a diameter. On the Charger Taurus problem, we had a diameter. This is a radius, 2 pi r. So 26 pi inches is a revolution. And I put it like that because I need revolutions in the numerator, right? Okay, so, wait, I have a problem because stuff hasn't canceled out. I need to get rid of some units. So what do I know?
12 inches in a feet.
12 inches is 1 foot. And that'll take care of the foot and the inches. And the only units I have left are revolutions per
Oh.
minute. Okay? So, remember, you're dividing by everything in the denominator. So 44 times 60 times 12 divided by 26 divided by
26
pi.
Oh, can you do 26 pi or you have to do like
380.
If you do it together, it's gotta be in parentheses.
Time when I was
387.8?
Yep. So the answer answer is 387.848 revolutions per minute. All right? Get out your extra practice packet I gave you yesterday. When you have successfully done problem number 1, you're going to lunch. So you can do it with your partner. Let's do problem number 1 on the extra practice packet.
One red one. 60 minutes and 1 second.
Yes. Yes, you have that.
60 seconds. What? Tweet. Usually it's 60 minutes or 1 hour.
Come on.
60 minutes or 1 hour. Where are you getting there?
You get into that. Yeah.
So we got.
All right, I don't want you to be late to lunch. We'll finish this when you come back. Go ahead, head to lunch. Everybody back in your seats at 45. 45. Be on time. You actually got 2 calculators? Well, that's a good idea.